In this video, I want to discuss stoichiometry with delta H, with enthalpy. So, how I know I'm working with a stoichiometry problem with enthalpy is they will give you information about the grams or the moles of a substance. So you see right here how we have grams of KOH. So what that is telling me, if we want to know the enthalpy change of that with given grams, I'm going to use the stoichiometry approach. Now, before we get into the stoichiometry, let's answer these questions that are up here. The first question says, does the beaker get warmer or colder? So in order to figure out what's going to happen, we have to look to see where our delta H value is. Our delta H value is written in the products. Okay, so it's written in the products. Because this is written in the product side, what that indicates is that the reaction is exothermic. And if the reaction is exothermic, then that means the beaker will be getting warmer. So the answer here is the beaker will get warmer. Our justification as to why is because the reaction is exothermic, so therefore it releases energy to the surroundings. Now, the next question is the reaction endo or exothermic? We've kind of already answered that. So the reaction is exothermic. And the reason why I know that this is exothermic is because the energy is written here in my product side. Now, if the energy was written here in my reactant side, what that would indicate is that the reaction would be endothermic and the beaker would actually get colder. Endothermic reactions absorb energy. So, now that we've answered the first two questions, let's now get into the last question and work with the stoichiometry. So when we're working with the stoichiometry, we're just basically setting up a stitch. And here's what your stitch is going to look like. You start with whatever gram amount that you're given, and you're going to get into moles first. So to get into moles, we take the molar mass, which is the grams of that compound, for every mole. In the next stitch, we're going to incorporate our delta H value that's given in the reaction. And we're also going to incorporate how many moles of that substance is in the reaction. So, since this is exothermic, it will be negative 43 kilojoules per mole reaction. Now, what goes in this little box here in the stitch is the coefficient that you have in the balanced reaction. So the question is, what are we looking at? Are we looking at KOH solid or are we looking at KOH aqueous? We are adding 14 grams of KOH, so that will be the solid that we're adding there. So in my balanced reaction, I have 1 KOH there, so 1 will be the value that we put in there. So let me go ahead and rewrite this stitch. I'll use a different color here, and we'll work this problem through. So 14 grams of KOH divided by its molar mass, which if I look it up on the periodic table, that molar mass is 56.11. So all I did was added K plus oxygen plus hydrogen to get that value for every mole of KOH. Now for my next stitch, I'm going to plug in negative 43 kilojoules because it's exothermic for 1 mole of KOH in my reaction. So now it's just a matter of working through the math. So I'm going to take 14 divided by 56.11 times negative 43, and that value is going to be negative 10.7 kilojoules per mole reaction. There you go. And that's your final answer. So again, when do I use stoichiometry? Anytime I'm giving grams or moles of a particular sample. Now, If I was given moles of this sample, it already found the moles for me, and I wasn't given grams. Where I would start, I would not do that particular step because I'm already in moles. So what I would do is I would take the moles that was given to me in the problem, plug it in right here, divide by the moles that I see in my reaction of that particular substance, put delta H there, and you will get your answer. So I hope that's helpful. Good luck with the stoichiometry.